Our task here is simply to find the voltage drop across each capacitor. Let's label the voltages and let's call this one V1, V2, and the voltage, same voltage across these two capacitors. So let's call that V3. Okay. So there's a simple approach to this. We can combine these two capacitors, and to do that we're just going to add them together since they're in parallel, and we have something that looks like so. At the end of the day, the voltage across this will be V3, and then we can then combine all these three together to get the equivalent capacitance, and that will be CEQ, which will be 1 over the reciprocal, the summation of the reciprocal of all three. That's 1 over 20 plus 1 over 30 plus 1 over 60. And with the help of our calculator, we arrive at a value of 10 millifarads. Okay, so and we know the equivalent capacitance, so we can calculate the equivalent charge. Recall that since these three are in series with one another, the charge on each capacitor is the same. So with that, we can say that Q is equals to CV. Then that would mean that Q, the charge across each capacitor here, would be equals to 10 times 10 raised to the power minus 3 multiplied by 30, and that would be 0.3 coulombs. So there's a charge of 0.3 coulomb here, there's a charge of 0.3 coulomb here, and there's a charge of 0.3 coulomb here. With that, we know that V is equals to Q over C. So we can calculate the voltage across this one, which is V1. Can calculate V1, which will be 0.3 divided by 20 times 10 raised to the power minus 3, and that will be equals to 15 volts. We can go ahead to calculate V2, which would be 0.3 divided by 30 times 10 raised to the power minus 3. That should be equals to 10 volts. Okay, and then the charge across this one, which is V3, the voltage across, which is V3, and that will be 0.3, which is over 60 times 10 raised to the power minus 3, which would be equals to 5 volts. So, and this also, so we know that the voltage across this is 15 volts, that across this is 10 volts, and that across these two would be 5 volts each. And that is how you find the voltage across each capacitor in a capacitive network. Bye.